Thank you. Well, actually, I'm standing on the shoulders of giants because I took Jason Thurnheer, the ultimate CMake guide. He has a podcast, and one of his titles was the Ultimate CMake Project, and I took that. And the other one who is involved in this is Chris. I think at CPPCon 2016, he made a Match 3 game for WebAssembly and for desktop. And I thought it's a good idea to port that to a microcontroller. So, why did I do that? Because the CMake is quite similar to the CMake we use at our company, but I can't show you code of our company. We are producing eye surgery, medical devices, but we also have a repo similar built up like the one I now created. We have different microcontrollers, we have different algorithms, where we also use dependency injection like Chris used for his talk. And our requirements, we want to easily add new libraries to our CMake. We want to have multiple platforms, compile for different microcontrollers. And we want a high quality of our new source code. That's quite convenient because we used Jason's blueprint. And some sort of dependency management where we can get our test tools or some other libraries into our project. So this Match 3 game has 4 dependencies now. Chris used BoostDI, the dependency injection library written by him. It's the Boost SML state machine library, also developed by him. It's quite common, and I think it's mentioned in a couple of talks. Then he used Ranges v3 to implement the game, and I took TouchGFX from ST Microelectronics. I just took the development kit and used that framework. So the basic idea is we have our CMake folder where all the CMake dependencies live. Then there's a configuration. There's actually every folder will be a known static or interface library, depending on if it's a header only or static library. Then Chris used a nice model view controller architecture, so I thought that's quite a nice architecture. He uses dependency injection, so it should be quite fairly easy to port it to the microcontroller. I then, of course, noticed I need a controller for the desktop. There's events, like down events, where he uses STL2 or mscripten with STL2 extensions. So I needed to adapt that, and of course use the TouchGFX click events. So that's why we have 2 controller libraries. There's a core library, the data, like the images, Then the actual executables, one for the desktop or WebAssembly, one for STM. We have the model and the view. And we use a top-level CMake just to add all our submodules or static libraries and set up and make all CMake functions available. So there's the first target, an interface target called project warnings. This is an interface library, so we can add compile definitions or linker options to that project. That's why we here include the compiler warnings. This is took over from JSON. It's just setting all compiler flags. Then, of course, as I used here, is FreeRTOS is on there, CMSys, and all the libraries. So I need to compile assembler, C code, and C++ code, and not all of them can be added to the compiler flags can be added to the C compiler. So I used generator expressions just to add specific C++ warning levels to the warnings. Yeah, like that's even one of my favorite, the old style cast, because I already saw many times that by using a C-style cast, one unintentionally casts away const, and that leads to undefined behavior or could lead to bugs, hard to find bugs. So we enforce everybody to use the proper static casts if needed. Then, of course, depending on the compiler, we just add those warnings to the project warnings. Here we can call the function with project warnings. So every static library that links to the project warnings will then have this level of warnings. Then also, as quality is a high goal for us, we also have the CPP check integrated. One just can set the flag and compile it with CPP check or Clang tidy. Include what you use. It just actually works out of the box. Then there's an issue. If you use, like I did, you use third-party libraries which don't follow the same standard of warnings, you get problems if you include those headers, or you might get warnings from those header files and you don't want to fix those warnings in other libraries. So there's a little function I wrote called target link libraries system, where you can just give in your target and the scope, and it will then, for the include directories, add the system keyword for your compiler. So the compiler then will ignore the warning flags on those included headers. Then, of course, if you have a header-only library, you get the problem that there's nothing to link to. So I made a target include directory system. So it's actually the same, just you get the header file passes. Then we set an option, enable testing, because our tests don't run on the device. So we actually do test our code on the desktop. So we have a flag to enable those. Then we actually do another library for the project options, where we can enable sanitizers. So we can compile the code with the sanitizers enabled to find bugs. We recently had a bug where it only in a release mode crashed, and the memory sanitizer was a very helpful tool to find the bug. So also here you just set the options, thanks to Jason Thurnheer, and it even warns you if you try to combine sanitizers which don't work with each other. Then CMake has no build type, so I just actually default to debug because our CI/CD will always build in release and do the test in release, and normally I'm just too lazy to type the build type, so I will default to debug. Then also we have the set export compile commands. This will generate a JSON file which can be picked up by the Clang language server, for example, so you can have auto-completion in nearly every IDE. Then also the dependencies. I include the dependencies. Catch2 is used for unit testing, and Trompe-l'oeil is used for mocking. So these only will be included if enable testing is enabled, so we can save a little bit of download and configure time. And of course I need to fetch SML, and I need to fetch boost DI, dependency injection, and the range is v3, so I can actually compile the game. Okay, now of course we want to compile it for a microcontroller. So if you give CMake a toolchain file, it will always set this CMake cross-compiling variable for you. So let's get a look at STM toolchain file. So I need to set that, hand it over, and the toolchain file, basically I need to set CMake system name to generic, because we actually don't have a real system, and CMake try compile target type, because CMake always tries to test your compiler, and with this line you can prevent CMake from trying to do cross-compilation, which obviously will fail anyway. Then a little convenient function for Windows and Unix. So I set up a search command and then can search actually for the ARM non-IRB GCC. And then set the found GCC compiler, also the assembler, C compiler, C++ compiler. Then for convenience, I set myself the object copy tool to generate hex or binary files out of the ELF file, and the size util tool, because I'm also interested, if I'm compiling for the microcontroller, how the flash layout looks like, also how much space I'm actually using. Also important is that we then say, CMake, please don't use our normal C or C++ runtime. I provide you with the in-util path, which we have found before. Then don't use that path for the programs, and get the libraries and the include path from there. And add definitions for the STM32 microcontroller, which is on this board. These are just, framework forces me to use them. And finally, I set the linker script. I just forgot to mention, we also set the CMake system processor to our target, though I can actually, by including some source code, define if it's suitable for that processor architecture. Oops. So now go back to the top level CMake. So if I'm now handed over that toolchain file, the flag will be set, and we go to the CMake set cross-compiling. There's the function. I also have a emscripten toolchain file, so I can there easily just set the options needed to build with emscripten, or if it's the GCC compiler, I'll add whatever functions and link options I need. We heard in the previous talk, like we need to specify the MCU, the float interface, the nanospecs, and unfortunately I needed to enable exceptions, because ranges v3 has some sort of a variant. It wants to access a variant in a bad way, so there's a throw in there, and I couldn't get rid of that. So then I'll just also add those compile definitions to the project options, and can link then every one of my sub-projects can link together. Then also the generate elf, we have a function. So we do post-build commands after compiling the whole thing. It will then print me the size, and here just generate the hex and the binary file, which can be used. Then if I enable testing, I also include C-test. So C-test will pick up all of my unit tests, and I can just run the C-test command and everything will be run. Of course, add the test folder, then adding all the sub-modules, configure, core, model, and then by differentiating if I'm cross-compiling or not, I just add the executables folders which define then the project. So then one small problem I actually had was with the interrupt definition. In the startup code, normally you have all interrupt definitions there as weak symbols, and at some other place you actually have the right implementation for those interrupts. And if you compile that as a static library and link those together, the linker just will skip your definition and use the weak link symbols. So I just compile it as an object library. It's just a bunch of object files, and the linker can pick up your definitions for interrupt vectors. And I needed to tell CMake there's an assembly file that it knows how to compile the startup code. So yeah, that's about it. Here we have the actual executable. So we set it a name, add executable, project name, generate the elf. This will produce me then the nice output of the size and the generate hex and binary files. I need to link, of course, to all my other libraries. You see the drivers and middlewares were a little bit polluting my warnings. So I just used my function to add those, and I could link my model controller view project options, project warnings to the executable, and then I'm actually good to go. Yeah. So that's about it. If there are any questions.
Well, thank you very much. Who has a question? Okay.
Hello. Actually, I have two questions. First is why don't you just use the find program function for locating the compiler executables?
Sorry, sir?
Find program function from the CMake.
Good question.
Yeah, because it actually does exactly what you did, but you also can provide some hint paths, so you don't need to have your toolchain in path, so it's easier to manage the stuff that is accessible in shell. There's no dependency of such utility as where or which, so few ifs less, and CMake can actually give you an error if it doesn't found the executable. So this would be nicer. And why are you using several project directives across the source tree? Because you have project in the top directory, then you have projects in different subdirectories.
Yeah, I'm just this may be my personal problem. I like to use the project name here because yeah, sometimes there are typos, or I'll change a name accidentally and then I'll get 1,000 problems. And here I only have like one definition of my variable, and I just use it and don't get any conflicts because I always have to repeatedly use the same name. Yeah, I could also set it, of course, as a variable,
yeah,
but yeah. Not quite sure if that's bad practice. Could be, but yeah, it helped me just get used to it.
Yeah, sticking the name of the library in the variable is something that I saw in many projects. So the size by building dozens of projects inside a single build tree, source tree is not something that I've seen very often. So that's why I asked, is there some technical reason for it?
It's not a technical reason. It's just, yeah, it didn't hurt me, and it's just convenient. I just need to write one line less.
Okay.
Thank you very much. Any more questions?
Is this project open source somewhere?
It.
Nice.
Yeah.
It's on the stream now.
Yeah. Yeah, that's why I actually ported the game so one can use the CMake tools here. Actually, a disclaimer, you're not allowed to use the touch GFX on anything else than an ST microcontroller from the license perspective, but the CMake you're free to use.
Any further questions? No? Then, thank you very much. Great talk.
Good. That's it.